Good afternoon. I guess it is time to continue with our program today. Hope you enjoyed the lunch. Again, compliments to organizing committee for excellent organization. We have just 5 minutes of delay, so we are not so bad so far. I have pleasure to introduce you the next speaker. Next speaker is Dr. Fedor Mesinger. Dr. Mesinger holds PhD degree from the University of Belgrade, Faculty of Natural Sciences, Department of Meteorology. Nearly half of his research career he spent in USA. And his main expertise is numerical atmospheric modeling. His main contribution is so-called ETA model that is used for weather forecasting as well as for predicting regional climate change. Dr. Mesinger became a full member of Serbian Academy of Sciences and Arts in 2000. Please, Dr. Mesinger.
Thank you very much for this wonderful introduction, and thank you, ladies and gentlemen, for coming back from this wonderful lunch. I must just correct a little the introduction. Models, numerical models, are a very, very big collection of codes and ideas, and I've just contributed a part of this so-called ETA model. And I anyway, okay, but let me not continue introducing myself. You have read already the title, and the beginning is a bit of a duplication of a talk we already had on climate change, but I hope you will not mind. Not everything is identical. I chose for the beginning to show you pictures of some of the grandfathers of the climate change business or science, and have several pictures. I'll start with John Tyndall, who was the first to measure absorption of various atmospheric constituents in terms of various wavelengths. And he was a mountaineer and was interested in climate, even though he was experimental physicist. And he discovered that absorption efficiency in the infrared of carbon dioxide is much greater than in visible region, and he was surprised. And he did speculate that this could be related to climate changes that geologists talked about. Svante Arrhenius came 30 years later, and he was the first to actually calculate what happens if the atmosphere has more carbon dioxide. And he took a long time for him to calculate. Did not have computers, of course, at the time. And I think a year or more. And he arrived at a warming of 5 to 6 degrees Celsius if the atmospheric content of CO2 were to double. And he, living up there in Sweden, he suspected that future generations might have a much nicer, milder weather than he had. Milutin Milankovic is one of the giants of our science. He had no idea about these CO2 ideas and looks. But he was not an experimental physicist. He was primarily a mathematician, a man of ideas also, and he calculated what happens to radiation that comes to Earth, and as a result of three sorts of changes of the Earth's motion, and also as a result of all sorts of planets that move around. It was quite a complex calculation. It required about more than 300 various parameters. So it was a major achievement, and he came to understand that ice ages came as a result the changes in Earth's motion and in Earth's axis of rotation. It was not known at the time that this indeed is the pacemaker of the ice ages. It was later found out that indeed this was so. He was a romantic soul, and he wrote stories, and later in his life he knew he did a big he made a cosmic effort in terms of actual science. And in the later part of his life, he went to writing, and his writings are beautiful, if you ask me. I hope they get translated. A little bit is translated to English, but not much. In one of these letters he was writing to this lady friend, imaginary perhaps, he was considering what was going to happen if the humanity uses all the coal there is. What is going to happen? Turns out we have a lot of coal which we better not burn. Guy Callendar was the first to calculate what will happen, what warming might happen, using actual measurements. And this was before the current global warming. Turned out he was not really, he thought that the warming at the time was due to carbon dioxide increase, but we know it's not that way. Okay, Dave Keeling is behind the measurements of, he started measurements of carbon dioxide in the atmosphere, and noticed that this is really changing considerably. And this measurement that you have seen already is called Keeling curve. This is from Mauna Loa, Hawaii, 3 kilometers. You have seen this thing. Who is behind all this carbon dioxide? You have seen this, but just in a different way today, China, USA, etc. But then historically, it is the different thing. Okay, I do have looking. No pointer. I can use that one. Okay, this is total contribution from the beginning of industrial times. Per capita, of course, is different. This is just from the U.S. Input, and you can see coal is coal, oil, gas, just a tiny bit so far of sustainable wind, geothermal, solar. It's just next to nothing, but it is increasing rapidly and getting cheaper. So this is our hope that this will take over. This, you have seen this picture already, but not quite identical. This is just from one place that is doing these measurements. And this is you can see here at the end. This is the 2015. 2015 is the warmest year. It gets warmer and warmer, even though there are these oscillations. And we know what are the reasons behind. This is the Mount Pinatubo eruption. This was a very strong El Nino. And the El Nino we just had was also very, very strong. Note, this is just meteorological stations. They have, I tend to put sources, and you have sources on top or bottom in most of my slides. You can, with this, there is this other slide that also is putting in the ocean temperatures. And if you put in the ocean temperatures, you can see that 2015 is way, way up. 2014 is also the warmest, warmer than all years before, etc. So this so-called hiatus that many people have taken as a sign that global warming has kind of stopped is really not something to take much belief in. There are these oscillations for the reasons I mentioned, and in the diagram you just see, averages are taken over decades, and you can see the 1980s warmest decade on record. Next one is much warmer, the next one still warmer, etc. Every year warmer than the average of the previous one. Okay, let's go more into the history. It comes from Jim Hansen and Makiko Sato from a paper published in the proceedings book of the symposium we had in Belgrade in 2009, published by Springer. This is 65 million years ago when the dinosaurs had this problem and so on. This is today. Then the last 5 million are expanded into the middle diagram, and the last 500,000 are expanded into the bottom diagram. There is about 14 degrees cooling from this maximum PETM. There is an explanation what this stands for here. So that is a very strong cooling that the Earth has gone through in the last 55 million years. So you can speculate what could be the reason, sun's activity, this or that, but there is nothing that comes close to the carbon dioxide. So why this happens? Carbon dioxide is the only explanation we have. There are other gases that behave similarly to carbon dioxide, but they are not as relevant, not as influential. Same thing as this decades diagram, but in terms of Arctic sea ice, you have one decade here, next one here, next one here, decade after decade, there is less and less Arctic ice. And these are individual years at the bottom. I couldn't get the latest one of the kind, but I do have some more. This is the minimums that happened so far at 2012. You can see in comparison to the median of the years that are written down there. And this is the diagram I downloaded 2 days ago. This is the current year, goes down, and the dashed line is the 2012. That is the year of this very intense minimum that we saw in 2012. So the Arctic ice is melting. Also, Antarctic ice is melting. These are plots for one, Greenland, not only Arctic ice sheet, but Greenland, most importantly, Antarctica. These are, I have it at the bottom, these are ice mass changes per year, so they are negative every year. And the diagram, this is hundreds of gigatons of ice per year. So there is a lot of ice that gets melted. Just look at Greenland. This is 3 kilometers. Sorry, I went wrong direction. This is the Greenland topography without ice. So all this ice, this is 3 kilometers, 200 meters. All this is water. And if this all were to be melted, the world oceans would rise 7.2 meters. That is, of course, that would be catastrophic for very many beautiful cities of the world. So to change the subject a little bit, the world is getting warmer. What gets with the water vapor? The warmer atmosphere holds more water vapor. What does that do to precipitation? Of course, there is more precipitation generally, not everywhere. And these are diagrams from, there is a source down, National Climate Assessment, number 3. What happens if there is a rapid emissions reductions, so-called representative concentration pathway, 2.6. That is with very energetic reduction of the release of CO2, of the emissions. And this one is with business kind of as usual precipitation change. The dark brown, 30%, green is more precipitation. So generally what you could see doesn't look good. Where there is what precipitation, one gets more precipitation. At places, if one can simplify this result, at places which are dry, they get still drier. So that doesn't look good. We get big storms. This is what happened in a city just, I don't know, 40 kilometers very near Belgrade, Obrenovac, May 2014. And this is the storm that was sitting on top of Balkans for days and resulted in all these floodings. People died, things were destroyed, of course. People who are in insurance business follow these things. This is from a book by insurance company, Geological, the number of global natural catastrophes. The geophysical events, of course, do not change much in terms of frequency, but all these atmospheric meteor storms, floods, etc., they get more and more numerous. I should go quickly, but I don't have much left. What happens if we continue burning the coal, as we mostly do today? The Earth contains a lot of coal, for a lot of fossil fuels, gas, also natural gas. The Earth has enough fossil fuels to increase carbon dioxide by about 5 times, at least. And there are diagrams people have calculated, and would not look good at all. The life on Earth would get in trouble. And I need to go now to my promised future, Paris. This Paris Agreement, and all looks wonderful. Top people came and signed things, but we can only hope that looks very good, but we can hope that this goes as promised, and also that is not good enough. Look at this plot. This is how much CO2 was emitted to date, and this is what happens to global temperature change. So we are already about 1 degree warmer than the Earth was in pre-industrial times. About 1 degree, the Earth near surface is warmer already. And if we burn twice as much, then the Earth gets, we get to here, and then we get to 2 degrees. So this proclaimed limit, desirable limit of 2 degrees, is kind of close. A couple of decades of going as we are would get us to the 2 degrees. But even 2 degrees is not something to be happy about. Jim Hansen, who is the leading, I think, advocate for the danger to humanity because of the burning of fossil fuels, says that 2 degrees is a prescription for disaster. We do not know well what happens to these big ice masses of Greenland and Antarctica, and there is a real danger that the melting will go faster than you can speculate or obtain by running various codes. We don't know. And also there are these island nations that get in big trouble, and places where people live that get flooded. We also have Venice nearby that already has trouble with things as they are. I just have a couple of more slides. This just describes what these representative concentration pathways are. They are defined in terms of the extra heating in terms of watts per meter squared. Okay. These are prescriptions or forecasts of what happens to temperature with various concentration pathways followed. But really only this 2.6 is one that really looks acceptable. Some calculations that come from our place, Belgrade. There is this ETA Belgrade University model with the Princeton Ocean model to do the ocean regional model, and what happens in Balkans. This is precipitation, change in annual precipitation gets drier, but not that much. So that is not the main danger here. But there is a bad side to it. See, this is from number of models on this plot. See, there is the reduced precipitation in summer or June, July, when precipitation is really needed. So the amount is not that bad for projected, but the distribution through the year is not good. Sea level is, looking at humanity as the whole, sea level is the biggest danger. See, these are past and projected changes, satellite data, etc. Sources are here down. From 1 feet comes from US, so they are still in these places in terms of feet. 1 feet to 4 feet and even 6 feet. That is very, very much. Not very, very much undesirable, to put it mildly. And to end up with some pictures, this is the iceberg shaving off, dropping down. You wouldn't want to be nearby, of course, when this happens. Photographer clearly was, well, if there was a live photographer, was not nearby. And see what happens at Greenland. These people must be well protected against slipping, because if one were to slip in this so-called moraine, would be in big trouble. So hopefully we need to be optimistic, otherwise we are not going to do what needs to be done. But let's hope we can really achieve in the end doing what needs to be done. Thank you.